Our team has developed an app that matches people with hikes. This is done using two machine learning models, an image classifier and a recommender system. This is all presented to the user in a Flutter application. The app sends user-generated feedback and requests for hikes to the custom-built API, which manages the models. The image classifier analyzes images taken from hikes and tries to identify characteristics that the user would like. This works in conjunction with the recommender system, which then tries to recommend hikes to the user. These hikes get sent back to the app for the user to swipe, and the cycle continues after the user finishes swiping on the batch of hikes. Let's walk through the mobile application. When we start the app, we are greeted with the sign-in page. On this page, we can either log in to a previous account or sign up with a new one. If it's your first time using Trailblaze, you'll be asked for a name, email, and password. Since we already have an account, we can just enter our email, password, and press the login button. Once we're logged in, we can see that there are three main screens: the profile screen, the hikes screen, and the matches screen. We'll come back to these in a minute. On the profile screen, we can select our preferences for hike length, elevation gain, and difficulty. Perhaps we only want hikes, which are rated as easy, have an elevation gain of less than 350 meters, and have a total length of over 10 kilometers. These preferences will be saved to the backend so that in the future, we will only get hikes that match these preferences. Our hike screen is empty right now because we need to hit the refresh button. Refreshing brings up hike cards. We can swipe vertically on the images within the cards to see more images. If we like a hike, we can swipe right on the card. If we don't like a hike, we can swipe left to dislike it. Alternatively, we can use the buttons at the bottom to either like or dislike a hike. Hikes get automatically refreshed when we run out due to API calls. If we head over to our matches, we can see hikes that we've already matched with. If we take a look at the first hike, we can swipe vertically in the image again to see more images. We can also see details about the hike, such as location, difficulty, distance, elevation gain, and the hike type. If we decide that we don't like a hike, we can reject it, and it removes it from the list. If we want to see more details about a hike, we can click this button, which takes us to the All Trails page. On this page, you'll be able to find more details about the hike, like more photos, a description. You can also see the tags, a map, and some reviews left by other users. We can hit the back button to go back to the app, and we can keep viewing the hike, or we can go back to look at our matches, or we can even keep swiping on some more hikes, or go back to our profile. Then, if we so choose, we can click the logout button to log out. This will take us back to the login screen.
The first machine learning model we use to match users with hikes is a recommender system. The purpose of the system is to recommend hikes similar to hikes liked by the user in the past. If a user tends to like hikes that are dog-friendly, long, and of moderate difficulty, the recommender system will find hikes that match those characteristics and show them to the user. To implement the system, we created an attribute vector of 19 hike attributes that relate to the user's ideal hike. Each hike in our system contains the same 19 attributes that relate to the information for that hike. Each time a user reviews a hike, their attribute vector is updated to reflect the attributes of the liked hike. When a hike is requested, the cosine similarity function is run on each hike's attribute vector with the user's attribute vector. The hikes that contain attributes similar to the user's ideal hike receive a high similarity. The most similar hike is picked out. Let's walk through a quick example to demonstrate how it works. The user likes 10 hikes that are of easy difficulty, are short, and are dog-friendly. The user's attribute vector is updated to reflect the fact that they prefer these hikes. When the cosine similarity function is run on all potential hikes, the hikes that contain these attributes are picked out and recommended to be sent to the user.
The second machine learning model used in this project is an image classifier. The purpose of this classifier is to identify features found in images related to a hike which the user likes, and recommend new hikes based on these features. For example, if the user often likes hikes with mountains and lakes, the classifier will tend to pick out these features and recommend more hikes which have images of mountains and lakes in the future. For our image classifier, we used a pre-trained ResNet 18 model because of its simplicity and fast training time. This model is used to classify images taken from the popular hiking website alltrails.com. To train the model, we use the images the user has already seen, labeled as either liked or disliked by the user. Because of this fact, the dataset is small by most standards. To compensate, we combined the simple model with lots of data augmentation to increase the effective dataset size, which gives better results without overfitting. Let's walk through the classifier's workflow with a simple example to demonstrate how the classifier's two primary functions work. The first function is adding rated hikes to update the dataset and train the model. This happens when an API call is made to post reviewed hikes to the backend. The classifier receives the name of a hike and its rating by the user, and then finds the matching images in the unrated folder and moves them into the liked or disliked folders, updating the dataset. Once 10 hikes have been rated, the model will recompile its dataset and train for one epoch. The second primary function is to predict which new hikes will be liked by the user based on the previous ratings. Just after the model has finished training on the updated dataset, the image classifier receives a list of new hikes. This list is a short list of the top 20 hikes for the user picked by the recommender system. The classifier takes each hike from the shortlist and predicts if it will be liked or disliked by the user. It does this by looking at 3 of the hike's images, computing a score for each image individually, and predicting its rating based on the mean score of all images. If a hike is predicted to be a dislike, it is removed from the list. If a hike is predicted to be a like, it is approved and moves on. The resulting list of approved hikes is then prepared to be sent back to the application, where the new hikes can be viewed and rated by the user.
From the start, Trailblaze was designed to be more than a hike recommender. It was made to connect hikers with the scenery and vistas that make hiking so rewarding. This is the big reason we used a visual classifier to suggest hikes, because some things can't be easily captured in numbers and keywords. We chose to put Trailblaze on your mobile device so that you can find your next hike from any location. You shouldn't need to sit down at a computer to connect to the outdoors, so the Trailblaze app gives you the ability to swipe on the go.